So this video is going to cover section 12.2 vectors in 3D, and it introduces one or two new things about vectors. Now you'll remember from mechanics we talk about the unit vectors I and j, and they were vectors which are 1 unit long and in either that direction or that direction. And I suppose you could say the coordinate of this, if it's 1 unit long, is 1, 0, and the coordinate of this point, if it's 1 unit long, is 0, 1. Now we can extend that to 3D and then have a third vector, unit vector, and that's the unit vector k. Now again, trying to draw what this might look like in 3D. So imagine these laying flat on the ground like that. That's 90 degrees, and then you've got this other vector sticking up like that. Again, that's a 90-degree angle there. And if it's my vector I, vector j, vector k, if I write down the coordinates of those three vectors, then in 3 dimensions, I is going to be 1 across, but 0 up and 0 back, and then up. J is going to be 0 that way, but 1 that way, but no that way, so that's 0, 1, 0. And then for k, you can probably see the pattern. It's going to be 0 that way, 0 that way, but 1 that way. And what's important about a unit vector is that its length is 1. So a unit vector has length equal to 1. Okay, and we'll be doing a little bit more on unit vectors in a moment. Okay, so you can take any coordinate and you can express it in terms of I, j, and k. So we'll have a quick look at example 4, and then you'll see that on page 339. And it's got these 2 points, A, which has position 1, 5, minus 2, and B, which has position 0, negative 3, 7. And write the position vectors of these two using I, j, and k. Well, that's easy enough. So it's how many i's, how many j's, how many k's. So this one would be I plus 5j minus 2k. So they're all unit vectors. So you're saying 5 lots of this, negative 2 lots of that, and so on. So it's very easy. So this one would be, well, there's no I. I suppose I could put 0i, but there's no point. Minus 3j plus 7k. So you can easily write a coordinate in this format where you've got j and k. It's just my mouse dropping on the floor there. If you have a look at example number 5, also on page 339, and it's given us the values of A and B, and you want to find 4 lots of A plus B. So you're just multiplying them up. So if A is 2 minus 3, 5, written as a column, so you can write these vectors as a column like this or side by side, and B is 4, negative 2, 0, then if I want 4 lots of A plus B, basically I want 4 lots of that plus 1 of those, and it's a very easy. So for that, that's 8 plus 4, 12. Okay, 4 of these, minus 12, minus another 2, so it's going to be negative 14. And then the last one, 4 lots of 5 is 20, plus nothing is 20. So there we go, nice and easy. So you can, I won't go through the other bit because it's very straightforward. Okay, state with a reason. It says whether either one of these vectors is parallel. So parallel to this vector 4i minus 5k. Now I'm just going to tell you generally, if you've got a vector which is parallel to another one, it's going to be a multiple of it. So any multiple of a vector is parallel to a vector to another vector to another vector. Yeah, so it's easy enough. Is the vector that I've got a multiple of that? So like 8i minus 5, 8 minus 10k, or even a fraction of that. Now I can see straight away that this one definitely isn't, because this has got 0j, and any multiple of 0j is 0. So it's not that. And I'm guessing when we work out the second one, which is 2a minus 3b, am I looking at the whole question? 2a minus 3b. Now if we work that out, it's going to be 2 lots of a minus 3, 5, minus 3 lots of b, which is 4 minus 2, 0. So if we work that out, that's going to be 4 minus 12, so negative 8. Then negative 6 plus 6, 0. That looks promising. And our last one, 10. Well, minus nothing is just 10. Right. Now, is this a multiple of this? Yes, it is. If I times this by negative 2, I'll get this, because this is basically minus 8i plus 10k. So yes, this is a multiple of that. So it's parallel. Yeah, it may be going in the other direction, but it's still a parallel vector. Okay. If you see a little vector and they put like a little hat on the top, like this, okay, that's the notation we use for a unit vector. Okay, that's basically a vector that's length is 1. Now, if you take any vector and you divide it by its length, you get a unit vector. Yeah, and you'll see in example 6, and this is on page 340, we've got this vector A, which is 2i minus j plus 4k, and we want a unit vector. So we're going to preserve its direction, but we're going to divide it by something. So basically, there's the vector. Let's divide it by its length, so we can write it like that. So this 2i minus j plus 4k divided by the length of this vector, well, that's just the square root of 2 squared plus negative 1 squared plus 4 squared. In other words, 4 plus 1 is 5. 5 plus 16, that's going to give us a length of 21, I think it's right. Yeah, so square root of 21. Now you can leave it like that, or you can write that, you're going to write it like this, 1 over the square root of 21, and then just put this vector in brackets like that. Okay, so there's lots of different ways that you can write the answer. Moving on now to example 7 in the book. Here this is asking about trying to find the, I'm just going to focus here, trying to find, there we go, the angle between a vector and an axis, and they start off by asking you to find the angle between a vector and the x-axis. Okay, now the actual formula for this says the cosine of the angle, and little x there just means the angle between the vector and x-axis, is given by x, in other words a vector for the x-axis, divided by the vector. So if you actually want the angle, then whatever you work out this to be, you're going to have to work out the cos inverse of it. So you can also have the cosine of the angle between a vector and the y-axis would be y over the length of the vector, and again the cosine of the angle between a vector and a z-axis will be the z-axis divided by the vector. Okay, so if I work those out, so in example 7, so I've got this vector A, which is 2i minus 3j minus k, and I'm going to find the angle between that and each one of the axis. So if I start with the first one, what I do actually is just take either the x part, the y part, or the z part, and that goes at the top. So if I want to find the angle between this vector and the x-axis, so I put 2 at the top because that's the x part, and I divide it by the length of the vector. Now for all of these, each one I'm going to be using the same length, so let's just work that out. So square root of 2 squared plus negative 3 squared plus negative 1 squared, so that's going to give us 4 plus 9, which is 13, plus 1, 14. So root 14 is the length of that vector. So 2 divided by root 14 gives us the cosine of that angle between that vector and the x-axis. So there's the x that goes there. If I want to find the cosine of the angle between that and the y-axis, then what I'm going to use up here is negative 3 over root 14. And then if I wanted to find the angle between this vector and the z-axis as a cosine, would be negative 1 over root 14. Now if you just do the cos inverse of each one of those, you will get the angle. So that's easy enough. Just work out what that is. Make sure you're in degrees. So for example, if I was doing this one here, I would just do cos inverse of 2 divided by root 14, and I would get 57.68 degrees or 57.7, and so on. You can do the same with the other angles as well. So the last example, example 8 on page 341, it's basically we need to show that this triangle is isosceles. Basically you've got these 3 points. One is the origin, so that's its coordinate. One is point A, and it has this coordinate 4, 2, 7. And then you've got this point B, which has coordinate 3, 4, negative 1. And then to show that this is isosceles, we're going to work out the lengths of each of these sides, and we should be able to show that 2 of these sides are the same length. So if I work out the length from here to here, so again, just work out the difference between those. So that would be the square root of 4 squared plus 2 squared plus 7 squared. Work out the length of this side. That would be the square root of 3 squared plus 4 squared plus negative 1 squared. And then this one, remember the quick and easy way to do it is work out the difference between these two numbers here that we have on the sides. There we go. So that would be 1 squared, because the difference between that and that is 1, so 1 squared. Difference between that and that is 2, so that's 2 squared. Difference between that and that is 8, so 8 squared. And then what we're going to do is work out the length of each one. Okay, so over here we have 16 plus 4 plus 49, 69, so you get the square root of 69 for that side, so we know that that's the length of that one. Over here we've got a square root of 3 squared plus 4 squared plus negative 1 squared, so 9 plus 16 plus 1, that gives us root 26. Oops, that's the length of that side. Over here, if we do this one, 1 plus 4 plus 64, so 64, 68, square root of 69. Right, so that means it's isosceles because those two sides are the same. 11.